Hey everyone, Mike from MyTekki here. I know lately we've been releasing videos on how to set up SQL Server, but recently I joined a project where we had to do some pretty intensive coding and we had to do a lot of real deep logic. Now, we had a junior database administrator aboard and unfortunately he wasn't understanding some of the code, and it was because people didn't leave enough comments. So I can't stress enough about leaving comments within your code to describe what your logic and what your thought process is, because your logic and your thought process might be different than someone else's. Today we're going to show you a simple function we built in order to receive data, translate that data, and spit it out. More explicitly, we take values that are delimited, such as like a CSV file. We incorporate that, we sift through it, we return each one as a row into a temporary table, which you can then essentially extract to another physical table within the system, and then at that point in time you basically can do whatever you want with the data. This function is great for CSV files or any other data that you might have that might be delimited that you want to be able to incorporate into SQL, possibly right on the fly without having to write a bunch of verification coding, so on and so forth. So we're going to go ahead and get started today. Notice I've already launched SQL Studio Management, as well as I've connected into my instance. And today we're not working on the SQL 2003 server that we would normally work on. We're just working on a local environment. Unfortunately, we're migrating servers right now, so there's no SQL 2003 environment up and running for me to test on, but it's the same concepts. So here we're going to go ahead and start off with, under the databases, we're going to go into our database, and we're going to go to programmability and functions. And it's not a scalar function, it's actually a table value function, because when we return the object, we're not returning a string of text or a scalar value. We're actually returning a table. It's kind of like almost a result set, so to speak, because the beautiful part about table value functions is that they get released from the memory right after the function is executed. So it's only in memory as long as the function is running. As soon as the function is done running, it releases it from memory. So you really have two things. You can keep it as a table value function. You can place it in as a stored procedure, so that way it's compiled and it's a little bit less memory within the system. If you're writing a big long function, you might want to consider putting it in as a stored procedure rather than a function. Again, because it is compiled at that point in time, you can use it as through executable command rather than using it as a function itself. So in this particular case, we were writing so many of them, we were using functions instead of creating a bunch of different stored procedures in our databases, and so therefore we kept it as a function. Notice how I always prefix everything. I'm very explicit when I name my variables or anything of that. In this case, it's a function. So I start off with fn, then split. Okay, because remember, we can always ignore it when calling functions. If it's in the database object category, we can always ignore the fact that that DBO is there, and SQL is smart enough to let us go ahead and just use fn split. With that being said, if you get in the habit of doing that, you want to kind of prefix what your database objects are. If they're a function, if they're, maybe if you want to get more explicit and say that fntb for function table versus function scholar. So let's go ahead and get into it. I've already created the function, so I'm going to right click and click on modify. Now note, one big deal here is that when you get the source that will be listed below in the description, this will not be alter, this will be create. Note that after you execute it for the first time, you've already created the function into the system. Okay, so you want to make sure that you definitely go ahead and change that after you do it once to alter, and you can save that off, because once it's in the system, you're not going to be creating another one because the object's already there. You're only going to be altering it. Now notice how you see a lot of green lines of commenting here, and that's because, again, I'm very, very paranoid about commenting, especially if you're going to be building a function or working on a project that's very portable from employee to employee, from department to department, from corporation to corporation. So what we're going to do is we're going to take a look at the function here, and we're going to define each thing. We have our standard setting the ANSI nulls to on and setting the quoted identifiers to on. More about those later. We're altering the function again because we've already created it, and you can notice that database object dot fn split for function split. Notice how I don't know how that got spaced, but notice how all the spacing is there, okay, and it is the first value comma second value. Again, we do this all the time to keep the code nice and clean for you to be able to read easily. Okay, so in this particular case, I'm saying, hey, I'm going to alter the function which accepts two variables passed through as parameters. One is going to be a list variable, which is giving me a varchar of 8,000 characters. Then my second variable is going to be the del variable, or short for delimiter. I'm saying it's going to be a character value of 1, and it'll equal to a pipe if nobody's passed any value, or if they put default or null. So a lot of people will use the default command. It's a very good idea if you don't know the value and you're going to be passing in, or you just want to use a default value that's stored within the function. Note, there is no such thing as an optional value within a function. You always must pass default. You can't define a default value and then when you call the function not even put the default word. The value must be there, because SQL doesn't check to say, okay, how many parameters are defined in the function and how many values did the user pass. If they do not equate, SQL will give you an error, and we'll demonstrate that in a second. So we'll keep going through here. You notice how we say it returns a table, okay, called table total assets, okay, and we're going to define the table that the first ID is going to be a big int, because we're using quite a large summary. It can't be null, and it's an identity value which starts at 1 and increments by 1. Okay, so then the value money will be the second field in this table. Again, it's called value, and we declared it as money as a data type because we were dealing with financial data rather than standard data that you might come up with in a CSV file. This is a very, very good tool for utilizing it on your CSV files, like stated before, and I highly suggest that you maybe modify it, again, maybe changing that to a varchar rather than money, because it can help you out quite a bit when importing stuff like that. So going down further, we then start say as, and then we begin our function. Right away you see what we're doing is we're declaring a complete list variable and assigning it as the list that we're passing from the user passing. So right here we declare the variable. Notice how the variable is the same amount of characters, the same data type, everything as the variable that the user is going to pass. Okay, that's very important. Then we select it, or you can use set or select. I personally use select. The complete list as list. We're actually assigning this now to the new function or new variable that we just created, complete list. Down below we go a little bit further. We're declaring and assigning the delimiter value passed by the user. If the user does not pass one, then the default will be denoted within the function. Now, first off, I need to learn how to type, but second off, this is a little bit incorrect only due to the fact that again, if the user passes default, that's what it should say. Again, you cannot not pass a variable, a very important a parameter, I'm sorry. So notice how we declare the delimiter as character 1, then we set the delimiter as del. Again, if the user passes default, it'll use the pipe that we said it was going to be the default up here. Okay. So we go down further. Again, I wrote a pretty big paragraph here, so instead of doing inline quoting, I use block quoting. you can use that kind of coding interchangeably. So you can see right here it says, okay, so here we're going to be declaring the so-called variable called value. In this instance, we will be dealing with nothing but monetary value, so therefore it is fine to data type this object so strict. Again, it's talking about the money value. Okay, we're data typing it as money rather than a varchar, and we're getting that strict because we are only dealing with money values. However, if you data type the object differently, there's no problem with that. Again, I explained that you can use a varchar value instead, and then at that point in time you can pretty much accept anything into it. Then we keep going through. We data type the start position as an integer. Okay, and the reason why that is, again, it is nothing but an integer. We're using it as a looped variable. And then after that, we go ahead and take the complete list. If it's greater than 0, we keep looping through and we update the complete list with substring functions. So let's take a look at the code. Right away, you can see that we're declaring the value and the money, the start position as an integer, and the length as an integer. Notice how we declared it right away within one line. You can do that, if you're declaring a lot of things that have to do with the same thing. You don't have to write multiple declares, especially if they're the same data type. Now, that's very important. They must be the same data type. You can't just simply start declaring variables at different data types in the same declaration, because especially if they don't have anything to do with it, you wouldn't want to do that anyways. So it's just another way to save you some some writing, so to speak. You don't have to keep writing a bunch of declares, and it looks kind of cleaner in my opinion. So note here that you're saying while the length, so the length of the string that's being passed through of complete list. Now note that complete list is also the list that's being passed by the parameter, by the function, by the user. It says is greater than 0. We'll go ahead and loop. Okay, so we begin the loop, and then we set right away the start position, which we declared up here as an integer, as the character index of the delimiter of the complete list. So it's going through the string and finding the first value it comes to. That is the delimiter, or that pipe in this case. Okay. Then we go ahead and say if the start position is less than 0, meaning the fact that it couldn't find one of the values. Okay, so less than or equal to, it wouldn't matter, it would still return the same. Then set the length to 0, therefore it'll exit the loop. Okay, it's the same. Set the start position to 0 and it'll exit the loop. Then we do the same thing right away with length. If the length is equal to the length of the complete list minus start position. Okay, so we're saying we're going to set the length equal to the length of the complete list, okay, minus the start position, which will give us however many values that the it went ahead. So if you had a 15 character value and then it found it on the 15th character, it'd be minus 15 and minus 1 to declare that ending off. We're going to kill that pipe basically off of it. So we set the length, and then we right away we say if the length is less than 0, set length equal to 0, and then of course the next loop it would exit because this would not equal true. So if the start position is greater than 0, what we're going to do is we're going to go ahead and at that point in time loop through again, but we're going to go and loop through the values. So we're going to say set the value, okay, equal to the trim, both L trim and R trim of the substring. So what substring does is says give me the text you want me to go through. Okay, give me a start position and give me an end position. Now notice how, I don't know, it's kind of confusing that it says start position over here, but basically I'm telling it to start the first character that is in the string and go to the start position. So again, if we're in the value of the function and we found it on the 15th character, it would be 15 minus 1, so it's going to go from 1 to 14 and return that text. Okay, in this case we're doing monetary values, so we're only dealing with like 3 or 4 spaces. So then it goes ahead and says set the complete list again, because we have that function up here, right? We got to keep decreasing it or we'll be in an infinite loop. So set the complete list to the trim substring. Now again, we have the complete list that's current, right? And we're going to go ahead and take the start position, add 1. Okay, so we're taking wherever it found it at, and we're adding 1 to skip that character one more time and any space that might be there. and then we're going for the length, because again, when you do a start value, it actually takes that start value. So you don't want it to take the 15th character, because that 15th character in this case would have been the pipe. Okay, so we're taking that and we're saying, okay, give me the length of the current complete list minus the start position, which would be minus 15, and now we get a total of whatever's left over within the string. And so at that point in time, you'll have whatever. So it'll then update it, and then it loops through until there's no more. Okay, and it will exit it, and then as you can see here, if the complete list was never even found, or the length wasn't even there, then we say, okay, set the value equal to complete list, set complete list equal to blank, and it will return basically a blank row. Okay, now we did use this. I took it out temporarily, but this is basically if someone passes a blank value. It's very good if you're going to do like an email list or something of that nature, and they pass a blank value through, and so you basically have a pipe, then a pipe, let's say. You can delete all those at the very end, and then at that point in time you can go ahead and clean your table up right on the fly. So you would just simply enable that. I've disabled it for right now just for demonstration purposes. Then we end the while loop, and then again right here we'll return the values to the customer, and then we end the function. So we'll go ahead and execute this, as I've made a couple changes, and we'll go ahead and start a new query and show you how it works. So we're going to do select, okay, and we're going to call the function, okay, and in this case we're going to say we have to treat it like a table, so we'll say select all from, and then basically this is a quote-unquote table. So we're going to say function split, okay, and then we're going to pass our variables. In this case, we're going to say it's a string of text, and we're going to say ABC pipe JKL pipe LMU. Okay, I don't know. I put some values in there, so we should get a result set back, because it's basically a table, okay, that will display an ID 1, 2, and 3, and then ABC, JKL, and LMU for the values. Again, we have to pass another parameter, and that other parameter again is, we're going to in this case use default, because we are using the default thing that we defined, which is the pipe. We'll end the function, and we'll go ahead and execute. And notice how it says cannot convert a character value to money, and this is a beautiful example of how strict we got within the function. It's telling you, hey, you gave us character values, okay? Our data type is money, okay? So what we can do is we can either change this to money, if we want to go ahead and just put like 25, 12, 10, and we re-execute this, it'll work fine. So there you go, 25, 12, and 10. So what we could have done if we really wanted to is we can just come right back into here. I'll show you how to display it or change it. Right here you can say you're going to give me a varchar, and you're going to give me a varchar up to, I don't know, we're going to say 25 per deal. We'll change the value down here to varchar as well. Now I'm going to equate it to the same thing over here. Now what this is saying is you can only have a 25 length value per segment. Okay, so once it gets delimited, you can only have that 25 length. Anything longer and it will fail. Okay, so we'll go ahead and re-execute this. Now you can't just save it, you must execute it to re-put it back into the system again, because you're altering the function. And we'll go ahead and change these to ABC, DEF, GHI, okay, and we'll execute, and boom, there it is. Now the coolest thing about this all is because a lot of people will create this and they want to know how many values they got in total, especially if you have an email list that you just got from someone and you want to confirm how many values you actually returned. What you can do is you can just say right away, okay, I see the list, it looks great, but did I get my true 500 emails or whatever, or did he jip me by putting a couple blank spaces in there? So you can just say count ID from this, and boom, you can see that you got 3 emails legitimately. Especially if you enable this the function down here where it deletes the blank values from the database, and then at that point in time you could see right away, hey, I got this many emails. So hopefully this was a good video for you guys, and if you guys have any questions, please go and leave comments or message me, and please subscribe to our channel and like this video. Have a good one, guys.